Every time you step onto a city street, you are walking through an invisible weight. Low-frequency noise from traffic, subway grates, and construction sites vibrates through the air and creates a constant baseline of stress in our daily lives. When that noise gets too loud, our first instinct is to build a wall. We put on a pair of thick headphones, assuming the dense foam and hard plastic will trap the sound waves before they reach our ears. But those materials only trap high-pitched sounds. Long, low-frequency sound waves carry so much physical energy that they pass right through solid plastic and travel straight into your ear canal. You cannot build a wall thick enough to keep the city out. To actually achieve silence, you have to stop trying to block the sound and start fighting it. If you look closely at the outside of a premium headphone shell, you will find a network of hidden external microphones. These microphones constantly measure the exact acoustic profile of the environment, intercepting the rumble of an airplane or a bus engine fractions of a second before that sound hits your eardrum. The headphone takes that incoming acoustic data and instantly generates a highly specific, customized counter noise. Active noise cancellation is an acoustic weapon. It constantly fires its own invisible frequencies outward to neutralize the environment. A sound wave is just a physical vibration traveling through the air. It operates as a continuous sequence of high-pressure peaks, where the air is compressed, and low-pressure troughs, where the air is pulled apart. Destructive interference perfectly inverts a generated wave to oppose incoming noise. The red line is ambient noise, and the blue line is the inverted anti-wave. Inside the ear cup, they collide. Peaks align with troughs. Adding to exactly zero, the air stops moving entirely. By aggressively pumping the exact opposite noise into the space around your ear, the two sounds destroy each other, leaving you with total physical silence. Sound travels at about 343 meters per second. That leaves almost no margin for error to intercept a wave, analyze it, and generate the counterattack. This requires a specialized microchip called a digital signal processor, or DSP. A DSP is a microprocessor designed specifically for executing mathematical algorithms on audio signals in real time. It calculates the necessary inverted anti-wave in a fraction of a millisecond. Because the microphone is on the outside of the headphone and the speaker is on the inside, the DSP uses feed-forward processing. Feed-forward processing is a predictive algorithm that calculates how sound will change as it moves through the headphone materials, ensuring the anti-noise hits your eardrum at the exact microsecond the ambient noise does. If that algorithmic calculation is off by a single millisecond, the peaks of the anti-wave will align with the peaks of the ambient noise. Instead of destroying the sound, the headphones will accidentally amplify it. Your headphones operate as hyper-speed supercomputers, continuously predicting and altering physics in real time to maintain your quiet. This manufactured physical silence has a strange interaction with our biology, specifically the tympanic membrane. The tympanic membrane is the thin layer of tissue in the human ear, commonly known as the eardrum, that vibrates in response to sound waves. When you stand on a busy subway platform, your eyes tell your brain to expect a chaotic, loud environment. But thanks to destructive interference, your auditory nerve reports absolute silence. This sensory mismatch often triggers a sensation of discomfort or cabin pressure. Your brain interprets the sudden, artificial absence of low-frequency rumble as a sharp change in atmospheric pressure, tricking you into feeling like you are rapidly ascending in an airplane. Active noise cancellation severs the evolutionary link between your physical environment and your sensory perception, hacking your biology to create a private auditory room. We achieve silence in the 21st century by literally fighting fire with fire, using localized noise to destroy external noise. This specific audio technology points to how we increasingly use algorithms to curate and control our immediate reality, filtering out the inputs we prefer not to process. For thousands of years, humans had to adapt their bodies and stress responses to noisy, difficult environments. Now we deploy predictive technology to force the environment to adapt to us. The modern ear actively edits the world, stripping away the invisible weight of the city before it ever has a chance to reach you.